Okay, let's start with this question. This is Mock 2014, question 8E. So we have the circuit, figure 5, which this is the inner voltage, 12 volts. And if you look at it, the A part says calculate the PD between A and B as shown by a high resistance voltmeter placed between the 2 points. So there's a high resistance voltmeter which will be placed here, right? So let's try and draw it. So this is a diagram representation of the question. This is the question here. Just I've added some component due to A saying that it's a high resistance voltmeter. So this high resistance voltmeter will look like this. And actually, you don't even need to put this because current won't be even traveling here. The reason is this is the voltage out. This basically A and B, there's nothing here. There's no linkage here. So the circuit, if current has to link, because current goes from the positive terminal right up to the negative terminal. So when current will move like this, current moves like this and then goes like this, it will flow down here. Of course, this 30 ohm resistor, this 30 ohm resistor, will oppose a resistance of 30 ohms. So the current will keep going. And now we know the laws of current and electricity. Normally the current will divide itself since this is parallel. But you notice something, when you pass through this 10 ohm resistor, you'll be blocked here. There's no linkage. This voltmeter is for the voltage output of the current. Actually, this is not even supposed to be, I'm just representing it. But in this particular question, this is the voltage output. This is where I represented it by V or V out. So this means that as current is coming here, it is blocked. There's nothing to link it all over here, but there's a voltage, there's a potential difference. That's what I'm talking about. There's a potential difference between this point and this point, and that's what the question is asking for. So all the current coming from here, since it can't go here, you do a backward bias and come all the way here. So all the current coming from here will be passing through this 30 ohm and this 50 ohm. So what's the question asking for? That A, we should calculate the high resistance voltmeter passing between the 2 points. So we have to calculate the potential difference over here. That's the voltage. Potential difference of voltage, the same thing. And that'll be V0. But notice something that will help us out. This voltage and this voltage are the same. Remember, voltage in parallel are the same, while current in series are the same. The current here and the current here are the same. The voltage here and the voltage are the same. And this voltage here is the same and these two combined. Remember that voltage in series, voltage will divide itself here and here. I spoke about division, which means the voltage here will divide here and here. It won't divide here. Why? Because in this particular circuit, the current doesn't move here. The current will undergo reverse bias, which means this 10 ohm can be ignored. So the question can be basically like this. Well, we're looking for the voltage here. And we have the voltage here, we have the voltage at AB. So that's a little trick in doing it. So let's do some calculations. So first of all, we have to calculate the total resistance that is needed, because to get the voltage at any point n could be the number of resistor. We could call this resistor 2, resistor 1, resistor 3, although this resistor is not really useful here. So to get n voltage, the voltage at any endpoint, it is equal to the resistance at that particular endpoint divided by the equilibrium resistance or the total resistance, or that multiplied by voltage, input voltage. Input voltage is this one, the voltage from the battery, from the source. So to get the voltage at 2 V2, we need the resistance, the 50 ohm, divided by the total resistance. The total resistance in the circuit will be this one and this one. These are the two resistors, which 1 and 2 are the two resistors which are inside the circuit. Remember, the current will be passing here and here. Will be passing here. Why? Because this point A and B are not linked. This voltmeter is just to calculate the voltage outputs. So they are not connected. Current will not be passing here now. So it will only be between this and this. So the equilibrium resistance or the total resistance will be the resistance and this resistance, which are now in series. Since current does not pass here again, I'll be precise on that. And the resistance is series. We know that we can calculate the total resistance series by adding these two. So that will be 50 ohms plus 30. All of these allow this to add up to give an ohm. Since here it is ohm, this will add up to give another ohm. So multiply it by voltage input, which is 12 volts. So this adds up to this. The voltage at the second resistor will be equals to 50 over 80 ohms times 12 volts. And if you punch that in your calculator, it should give you 7.5 volts. So that's the answer. But this is not the final answer. Sorry. This is the voltage at these two. And now we'll add it into statement that is, since the voltage, the 50 ohm resistor is parallel to the potential difference, is parallel to the voltage output between A and B. Therefore, since V2, or you could call it anything, you could call it V50 ohm, whatever, is parallel, just represent parallel by this, is parallel to the voltage at AB. This implies that the voltage at AB is equals to 7.5 volts. So that's basically what has to be done for the A part. For the B part, a 40 ohm resistor is now placed between points A and B. Calculate the potential difference AB and the current flowing through the 40 ohm resistor. So we'll have to redraw it again.